Hey everyone, hope you're doing well today. In this video, let's go ahead and take a look at a couple algebraic properties together. Hopefully at this point you've learned about some other properties like the commutative, associative, identity, and distributive property. Typically, a couple of nice properties to learn in conjunction or in addition to those are going to be the additive inverse property as well as the multiplicative inverse properties. So today we're going to go ahead and talk about what those properties are, as well as go ahead and use them along with some of those other properties as well. Now, to get the most out of this video, I encourage you to grab some paper, something to write with, and let's do some math together. All right, so first up, we got this additive inverse property. It really just kind of means that when you go ahead and add a number to its opposite, what is going to happen? Well, opposite you can also think about as negative. That's another way to think about it. But the result is always going to be 0, right? So if you add two numbers that are equidistant from 0 or have the same absolute value, you're always going to get 0. You can also just call this the number that you're talking about, rather, is called the additive inverse. So the additive inverse of like 3 would be -3, or the additive inverse of -2 would be +2. So for example, using numbers, we could say 5 plus -5 equals 0. That's demonstrating using the additive inverse property. But this doesn't just work for 5, it works for any value, so we can use a variable a to kind of show that it works for any of these numbers as well that you could use. Now, it doesn't have to be a positive plus a negative, it really also could be like a negative number like -3 plus a +3. So maybe just go ahead and write that down so you don't get any misconceptions here. Also, you could have a negative variable first like -b plus the opposite of that, which is going to be +b, or vice versa, and that would also be equal to 0. Okay, so the negative can come first for sure using the commutative property, right? Next, we also have something called the multiplicative inverse property. So here, you can say that when you go ahead and multiply a number, it can't be by its opposite this time. It's actually going to be its reciprocal, rather, right? It also calls its multiplicative inverse. The result is always going to be 1, okay? So a number multiplied by its multiplicative inverse, we can say, is going to be equal to 1. So, for example, the multiplicative inverse of 5 would be 1 over 5. The multiplicative inverse of 3 over 2 would be 2 over 3. Those are just reciprocals, aka multiplicative inverses. Okay. If you take a look at some examples here, I just kind of mentioned one, but here's another one. 6 times 1/6, that just equals to 1. Those 6's can cross cancel. Using some algebra here, any value multiplied by 1 over that original value does get you 1 as well, right? Now, this works for negatives, this works for fractions, decimals as well, as long as they are reciprocals. And so this doesn't just work for positive numbers and when whole numbers first. You could also multiply like a negative fraction first multiplied by a negative whole number here. So maybe something like -2, right? These are reciprocals with each other because when you multiply them, you get 1. You could also call these multiplicative inverses of each other. That being said, you could also say algebraically like something like 1 over y multiplied by y would also equal 1. So this 1 over y would be the multiplicative inverse for y, and also y would be the multiplicative inverse for 1 over y. So you can think about it both ways. All right. Some other properties that we mentioned earlier were the distributive property, the two different commutative properties, the two different associative properties, and the two different identity properties. So just kind of bringing those back to the top here to keep them fresh in your mind. I know there's a lot of different properties to kind of keep track of, but today we're going to be using those other ones as well just to make sure we didn't forget about them and we can use them all together. All right, let's try some examples together. In example 1, we're just going to go ahead and see if we can identify if each of these expressions would represent either one of the properties we just kind of mentioned or neither of them. All right, so for this first one, we have -7 plus 7. What does that equal to? Well, it is equal to 0. So if that's the case, if it equals 0, what property would you say? We would just go ahead and say that this must be the additive, practice spelling it here, additive inverse property. Okay, so I know it's a little bit of writing here, but I think it'll be okay as long as we also are getting used to spelling these words and getting used to what they mean, right? But it does help us kind of wrap our heads around it. What about this next one? We have 8 multiplied by 1/8. Well, hopefully you agree that this is really just 8 over 1 multiplied by 1 over 8. So whether you do 8 times 1 over 8 times 1 or just cross cancel the 8s to make it 1 over 1, you do get 1 when you multiply here. So if that's the case, we can go ahead and say that this does represent the multiplicative inverse property. cool. So again, just practice spelling these words. I know they can be a little tricky, but it's important to be able to do that as well. If we take a look at the next one, look at this 5 and this -5. They are opposites, right? So you might be thinking of it would be one of these properties. However, if you multiply these, you get -25, right? So -25 does not equal 1 or 0. When you're multiplying, you should be getting 1, right? So since it doesn't equal 1, you would just go ahead and say this is going to be neither. Okay, it's not representing either one of these properties. For this next one here, you have this 3/4 and 4/3, and they are reciprocals, right? So maybe you're thinking of multiplicative inverse property because they're reciprocals of each other. However, we're adding here, right? So for adding, we would need common denominators. So you would multiply the first fraction by 3/3, and you get 9/12. Then multiply the second fraction by 4/4 would be 16/12. You can see here that this does equal 25/12, right? But when you're adding here, right, if you're adding, you would be using the additive inverse property. You should get 0. But since this does not equal 0, this is neither the additive inverse property or the multiplicative inverse property. So this one is neither one. All right, next for letter E, this one we have 4.5 multiplied by 2/9. If we're multiplying here, we should be maybe thinking of the multiplicative inverse property, but are these reciprocals or multiplicative inverses of each other? Well, if you go ahead and do big bottom plus the top and turn this mixed number into an improper fraction, big bottom, that's the big number times the bottom, 4 times 2 is 8, 8 plus the 1 on top is going to be 9, so this is what, 9/2 multiplied by 2/9. These look like reciprocals, right? You could cross cancel the 2's and the 9's to get 1's everywhere, and then you get 1/1, or you can get 18/18, which is also 1. So since 1 does happen to be the product here, these are multiplicative inverses of each other. So we can go ahead and write that this does represent the multiplicative inverse property. All right, cool. Let's take a look at this next one. For F here, we have positive 3.2 and -3 1/5 here. So we're adding here, so we should be getting 0 using the additive inverse property. Now, there's a couple ways you can kind of think about this. You can either turn this one into a decimal or turn this one into a fraction. I think it's a little bit easier for me to turn the decimal into a fraction. So 3.2. Keep in mind that 3.2 is the same thing as what? 3 2/10. Which is 3 1/5 here. So this is really the same thing as 3 1/5 plus this -3 1/5. So these are opposites, and you add these, you get 0. So I think we can go ahead and say that this does represent the additive inverse property. All right, cool. We got one more over here. Let's see if we can figure out if these are additive inverses or multiplicative inverses. Let's go ahead and look at this first one. Well, these are being multiplied, so we hopefully get 1 here. It's nice that they're both negatives to maybe be a positive 1, so that's important, right? And then let's go ahead and see this -24/30, the GCF of the numerator and denominator is 6, so you can simplify that fraction. If you go ahead and do that, you would get negative, if you divide both by 6, what would you get? You would get -4/5, right? If you divide them both by 6. And then what is this one over here as an improper fraction? If you do big bottom plus the top, big times bottom is going to be 5, plus 1 is going to be 6. So this is going to be multiplied by -6/5. All right, so these don't quite look like reciprocals, but they might be close here. 4 times 6 on top is 24, and 5 times 5 is 25. A negative times a negative does become a positive. 24/25 is really close to being 1, but it's not equal to 1. So in this case, you would go ahead and say neither. This doesn't show the multiplicative inverse property because you have to get 1 if you are multiplying here. All right, so hopefully you feel a little bit better about identifying these two properties and when it's not one of these properties. And so go ahead and now try simplifying or evaluating some algebraic expressions to see if we can tie this all together. All right, so let's check this out. We have an original expression here of 5b minus 2 times the quantity of 7 plus 1b plus 14 here. So let's see if we can go ahead and evaluate or simplify this expression and justify it using the justifications provided here. So it says go ahead and write the original expression. So we're going to go ahead and write, we have 5b minus 2 multiplied by the quantity of 7 plus b, or 7 plus 1b. You can always write the 1 if it helps you. And then I'm going to write plus 14 here. Okay. Then we're going to go ahead and rewrite the differences as sums. It looks like we only have one difference here, so let's go ahead and rewrite that. So we have 5b plus this -2. This -2 is going to eventually distribute, right? So think ahead about what that's going to look like. If we go ahead and distribute this -2, that's going to multiply by the 7 and this 1b. If we do that, we're going to get 5b plus, this is going to be -14, then plus -2b, and then plus 14. Okay. Let's go ahead and apply the order of operations here and put in some parentheses. So let's go ahead and put brackets in instead. So I'm going to put them in the beginning just because everything's adding, so we should go left to right. Go ahead and put that here. And then we can go ahead and just copy the rest of this. It's plus this -2b and then plus 14. All right, let's go ahead and apply the associative property. So that means we're going to move the grouping symbol around here. So if we're trying to think about how we could simplify this thing, eventually we want these two together because they're like terms, right? So we can combine them. And we also eventually want these two together, these constant terms. And we can also maybe use another property once we get those constants together. So, all right, now for the associative property, let's go ahead and move these brackets. I think it would be nice to kind of get these variable terms together here. So I think we're going to try to move the brackets so we can get and move some pieces around. So we have 5b plus. Let's go ahead and move the bracket here. So the associative property means we can move the grouping, right? So we have -14 plus -2b. These will go in the brackets together. And then the plus 14 is just going to hang out on the end here. Okay. Now we're going to use the commutative property. The only two things we can swap are these two because they're in the brackets, or we're being told to kind of look here. So inside these brackets, let's go ahead and change the order. It's going to be -2b plus -14. Go ahead and keep them in the brackets, but change the order. Now you can see that these two variable terms are next to each other and the two constant terms are next to each other. So that's really good, right? Let's go ahead and try to combine these by using the associative property and regrouping again here. So let's go ahead and put the brackets in front. If we go ahead and do that, it's going to be 5b plus -2b. Okay. And then we're going to have this plus 14 on the outside, or rather plus -14, and then plus this positive 14. All right. Next, we need to go ahead and rewrite the variable terms with a distributive property. So if you take a look at these two terms, notice they both have a b. So if they both have a b, what we can do is say, we can take the coefficients and say it's 5 plus -2. And then we're going to multiply that sum by b. All right, that's the distributive property, right? Because if you go ahead and distribute b to both of these terms, you would get back to these products here, 5b plus -2b. We still have this plus -14 and plus this positive 14 on the outside. Next, we're going to apply the order of operations. If you follow the order of operations here, we do have brackets. You have to look inside here, but inside here, we have another set of groupings, so you have to do what's inside here. So we have to do 5 plus -2. That's going to be 3. So we're going to be looking at 3b, which we don't need any more parentheses or brackets because it all kind of simplified down. 3b plus -14 plus a positive 14. Okay. Now let's go ahead and apply the order of operations. It says insert parentheses or brackets. If we're going to do that, it has to be in the beginning from left to right if everything is addition. So it's going to be 3b plus -14. Okay, just like this. And then the plus 14 is going to go on the outside. It says apply the associative property, which means what? It means we're going to move the grouping symbol. Let's keep the 3b plus. And let's go ahead and move the brackets over so it's -14 plus 14. And then let's go ahead and keep the two constants in the parentheses. And then it says apply the additive inverse property, which makes sense, right? That means these are opposites. -14 plus 14 is going to be 0. That's the additive inverse property. And then the identity property of addition says anything plus 0 stays the same. So 3b would be the most simplified version of this expression. All right, so hopefully this made sense. We went ahead and used some of the other properties we've talked about in the past, but we also used the additive inverse property once in there as well. But hopefully that makes sense when we added the opposites right over here, that we got 0. Okay, so hopefully that made sense. Let's go ahead and try another one together. Okay, in example 3, let's see, we have another expression here. We have -5y plus this product of 5x, y, and 1 over x. So let's give this one a try. All right, first things first, let's go ahead and rewrite the original expression, or just write it. So we have -5y plus 5 times x multiplied by y multiplied by 1 over x here. Okay, let's go ahead and follow the order of operations a little bit. We're going to insert parentheses. Now, where would we insert parentheses? I think we can, well, all the multiplication's tied. So we have multiplication, 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 multiplication. So a lot of multiplication here. What I'm going to do though is I'm going to insert it because all multiplication is equally important. I'm going to go ahead and insert it over here. So you could insert and move it, I guess, technically, but I'm going to put it right here. This doesn't affect any of the order of operations, right? So 5 times x, and then I'm going to keep this multiplied by y and multiplied by 1 over x on the outside here. All right. So as we simplify this expression, I'm just thinking it kind of makes sense, hopefully, to try to get this x and this 1 over x and put them next to each other, because if you multiply, you could use the multiplicative inverse property. So try to think ahead about like what you're trying to accomplish so that you can use these properties. All right. Next, we're going to use the associative property. So we're going to move the brackets here. Let's go ahead and see. I'm going to move it to the end here. So I'm going to say this is going to be negative 5y plus, and so we have 5 multiplied by x, but then I'm going to go ahead and move the brackets. So it's going to be this y being multiplied by 1 over x. And now these two are going to be in the brackets here. Okay. Now let's go ahead and use the commutative property and swap these two around so we can get the x and 1 over x next to each other. So we'll have this negative 5y plus 5 multiplied by x, and then we're going to multiply by the quantity of, we can say 1 over x multiplied by y. Okay. Next, we're going to apply the associative property. So where do you think we're going to move the bracket? So we have this negative 5y plus, and then let's go ahead and move the brackets. It's going to be 5 multiplied by, and in the brackets here, we're going to have x multiplied by 1 over x. And then let's go ahead and then multiply this by y afterwards. Okay. It does say to then apply the multiplicative inverse property, which makes a lot of sense as to why we wanted these two together. X and 1 over x must be reciprocals of each other, because if you multiply together, you get 1. So we have negative 5y plus 5 multiplied by 1 multiplied by y. Now it says go ahead and use order of operations and just insert parentheses again. So again, we have a bunch of multiplication that's tied. So I'm going to choose one to kind of go first here. It's going to be 5 times 1. And the reason why I'm choosing it here too is if you look at the justification that's next, it says identity property. So identity property, ask yourself what that means. Means we're multiplying by 1, right? So if you multiply 5 times 1, that's going to be 5. So that's using the identity property of multiplication. So we have negative 5y multiplied by 5 times y. You can go ahead and just apply the order of operations, just kind of simplify this down, simplify it. So it's negative 5y plus 5y. Okay, and these are opposites of each other, so you can actually use the additive inverse property here, because if you add these two, you actually get 0. So no matter what values of x and y you have, the whole expression would just end up equaling 0 no matter what here. So that's kind of interesting to kind of see how everything kind of boiled down to that, but we didn't even need to know the values of x and y. We know that no matter what, the expression will equal 0. So just to kind of recap here, we talked about two new properties in this video. The first property was the additive inverse property. It just states that when you add two numbers and get 0, that means you use the additive inverse property. If you multiply two numbers and you get 1, those are called multiplicative inverses of each other. You'd be using the multiplicative inverse property. And then we kind of identified when it was actually happening, when it wasn't happening here. Notice that if you don't get something that equals to 0, then it's not the additive inverse property. And if you don't get something equal to 1 when you're multiplying, then it's not the multiplicative inverse property, so it's neither. We took a look at an expression that we simplified here. We applied a bunch of our little properties along the way, right? We used the distributive property. We also used the associative property, the commutative property. We also even used what else did we use? That was unique, I guess. We used the additive inverse property as well as the identity property. So we kind of used, I think, almost every single one there. And then in the second example, there was no distributive property. However, we still used quite a bit of them. We did use the associative and the commutative, where we changed the grouping and changed the order. We actually used the associative again, the multiplicative inverse property when we got 1 throughout the problem, as well as if you multiplied something by 1 and it stayed the same, that's that identity property again. And then if you add two opposites and get 0, that's that additive inverse property. So hopefully you found this video helpful. If you did, please consider giving the video a thumbs up and sharing it with a classmate or friend who might also find it helpful. And as always, keep up the great work that you're already doing.